In this video of BobCAM for SOLIDWORKS, we will be doing a mill example. First, open your SOLIDWORKS software. We will then click File and then Open. The default directory for the BobCAM examples is the C drive, BobCAD Data, BobCAM v3 examples. If when you installed the BobCAM software you did a custom installation, you will need to locate this file. The default directory, Computer, C drive, BobCAD Data, BobCAM v3, examples. We will be working with the whole example file. Select it and click Open. Once the file opens, switch to a front view. Navigate to the SOLIDWORKS Feature Manager. Select the BobCAM CAM tree. In the BobCAM CAM tree, you may need to expand the CAM part folder in milling stock. This is done by clicking on the plus symbol next to each of these categories. Right-click milling stock and click Stock Wizard. We will need to define our stock. Select Cylinder. We will go with the automatic bounding box that is generated. Click the right arrow. We'll use the UCS at the center of the part. Click the green check mark and go back into a front view. The first operation that we will do is add the drill to the 6 outside holes. Right-click milling stock and click Drill. Select Hole and click Next. Click Select Geometry. You will need to rotate the part in order to select the bottom edges. Select the bottom edge of each of the holes. Once they are selected, click the green check mark. This brings in the diameter and depth of the hole. Once done, click Next. We're going to use an optimized pick order, blind. Our rapid plane is fine. Our top of part is fine, since the top of part has not moved from 0, 0. On the posting page, this is not an index part, so we'll click Next. We'll use the automatically generated center drill. Click Next. We will override the depth, and we'll make it 0.04. Notice how the center diameter also changes as well. Click Next again. We'll use the automatically generated tool and click Next. We will use peck on the hole. In this case, we will not override the automatic peck that is created, and then we'll click Compute. If we look at the part, we've now generated the drill cycle for the 6 outside holes. Go back into a front view. We're now going to drill the 3 interior holes. Right-click Machine Setup and click Drill, and then select Hole. Click Next, and click Select Geometry. We're now going to select the bottom 3 edges of the interior holes, and then we'll click the green check mark. Click Next. We'll leave the rapid plane and top of part alone again. On the posting page, this isn't a 4th axis, so we'll just skip it. Again, we'll call up the same system tool for the center drill. We will override the depth again. And click Next. Again, the program brings in the proper tool. We'll click Next again. And this time we'll leave it as a single depth and click Compute. Now what we will need to do is either profile or pocket this interior geometry of the part. We'll go into a front view again. Right-click Machine Setup and go into Mill 2 Axis. to the interior holes. With profile selected, click Next, click Select Geometry, rotate the part as necessary, and select the edge at the bottom of the pocket. With the three edges selected, click the green check mark, and then click Next. Notice how it brings in the geometry into this window. We'll leave the feed plane, rapid plane, and top of part alone. The feed plane is used to define the point at which the end mill starts cutting. We'll again click Next. Again, this is not a fourth axis operation. Click Next. We'll use the 1/2 inch end mill. Click Next. We'll do a standard with left compensation, no machine compensation. We'll do this to size, so we'll have a 0 side allowance and a 0 bottom allowance, but we will step this multiple times. We'll change the depth of cut to 0.125 and then click Next. We'll use a vertical lead in and lead out. We'll use sharp corners, and it'll do closest for machining sequence. Since we're doing this to size, leave the finish tool at 0 for size, and then click Compute. Notice how the toolpath is generated on the inside of the hole. At this time, we'll go into a front view again. At the top of the screen, click BobCAM and then Mill Simulation to go into the simulator. Slow the speed down at the top and then click Play. And as you can see, it center drills, pegs, and if we speed it up a little bit, we'll see it cut around the part. We can turn the initial stock off. And now we're seeing the profile toolpath cut the inside of the holes. Click the X or go up to BobCAM and click Exit Simulation. Now we need to define the interior pocket and the exterior profile. To do this, right-click on Machine Setup again and click Mill to Axis. We're going to select a pocket this time, and then click Next, and then click Select Geometry. We'll rotate and select the bottom interior edge of the pocket. Once it's selected, click the green check mark and then click Next. Again, we'll skip this page and go to the rough page. We'll use the 1/2 inch end mill. On the patterns page, we'll select an advanced pocket. This allows us to use the adaptive rough. We could also use a zigzag offset pocket in, and as you can see, the picture dynamically changes depending upon which is selected. So we'll use an advanced pocket with adaptive rough, and then click Next. This time we'll leave a side allowance for the finish tool. We'll do the part in 2 steps. Click Next. We'll leave the lead on plunge. On the finish page, we'll use the same 1/2 inch end mill. Select Next. This time though, we'll turn system compensation off and we'll turn machine compensation on. In order for machine compensation to work correctly, you will need to have a parallel, right angle, or circular lead-in of at least the radius of your tool for the finish pass or rough pass. In this case, we'll use circular with a 0.25 radius and then click Compute. Once the toolpath is computed, go back into a front view. Now we will add the last profile. Right-click on Machine Setup and click Mill to Axis. Be certain that Profile is selected and click Next. Click Select Geometry, rotate as necessary, select the top edge of the part, right-click, and click Select Tangency. This selects the tangent of the exterior edge. With it selected, click the green check mark and click Next. Notice how it brings in the geometry again. We'll skip the posting page and go to the rough page. We'll use the same 1/2" end mill and click Next. In this case, we'll turn System Compensation off, Machine Compensation on. Again, we're finishing to size, so we'll have a 0 side allowance and a 0 bottom allowance. We will need to enter the depth because we did not select the bottom edge. Enter 1 for the depth and select multiple step. We'll do it in 2 passes of 0.5. Click Next. Since we have the G41, we'll again need to have a circular lead in and lead out, or right angle or parallel. In this case, we'll select circular with a 0.25 radius. We'll leave the corner type as is, and we'll remove the Finish tool. Click Compute, and then go into a front view. Notice how the toolpath currently isn't shown in the part. This is because of the direction of cut. Currently, the toolpath is offset into the part. If we right-click on Start Point under the feature profile that we created, and click Reverse Direction, and then recompute the toolpath, we'll notice that the toolpath offsets outwards. If you want to rename one of the features in the BobCAM cam tree, simply right-click on it and click Rename. We'll call this Interior Holes. We'll call the pocket Interior Pocket, and we'll call the feature profile Exterior Profile. Once all the toolpath has been created, click BobCAM at the top of the screen and go into the mill simulation, or right-click Milling Stock and go into the simulation. In the simulation, click Play. This time, however, pause it, go into a machine view, click the slider at the bottom of the screen and drag it to the end. This will then show you the part as it's been calculated. We'll go into an isometric view and then exit the simulation. The part is now finished. Now that the toolpaths have been properly added, we'll be certain that we have the proper post-processor. We'll right-click on it and click Edit, and then click Select. We'll select our FANUC OM, click Open, and then click OK. We'll right-click Milling Tools, and then click Post, and we have now posted our code. This concludes this basic milling tutorial.